welcome to part 15 of my Tevo Black Widow mods videos. In this video we are finally going to start working on the control box and assembling it. So yeah, right now I'm working on printing the top layer of the control box, which by the way takes about 600 grams of filament, even with low infill. So yeah, it took quite a bit of time as well, even though I'm printing at 0.4 layer height, but as you can see now they are finally complete, and we can now move on to actually assembling and building the control box. But before I do so, I just wanted to show you this problem that I had with both of my prints. As you can see, they are not at the same height, but there are two layer shifts. I don't exactly know what caused these. Because of the fact that these aren't repeated in more layers, I'm assuming it's not a skipping step, but it's a different kind of mechanical issue, but I'm not sure what it is yet. So yeah, this is something that I'm going to diagnose after I'm done with the control box. Anyway, as you can see, I'm assembling the control box right now. I'll just assemble it as much as I can and then show you the result. So as you can see from the time-lapse, I'm having problem with attaching the top layer to the rest of the control box, and it's caused by the problem that I mentioned earlier, which I thought it wasn't going to be a big issue. Turns out it's important, and that is the layer shift. So because of the layer shift, two sides of the top layer aren't exactly in line, which means the holes don't match up, and because of that I can't attach the top layer. So I'm going to have to print it again. So as you can see, I'm printing it again. This time I'm printing it in a different orientation, so if a layer shift happens again, it won't be in a critical location. As you can see, it printed now, and there is no layer shifts, as you can see here. The one on the left is the old one, the one on the right is the new one. So yeah, that's good. The only problem is the top layer is now, as you can see, pretty terrible, and that's because there's some problems with the calibration of the BL touch and the heat bed, so that's just unavoidable. Anyway, this is where we left off. As you can see, the blades and the rest of the control box are now done. So all we have to do to finish the test assembly is to attach the magnets that will hold the door on the top layer, and then attach the top layer using the 6 screws in total, 2 on the back, 2 on the right side and 2 on the left side on the fans. And you might notice that I haven't printed the door yet, and I'm not going to print it today, mainly because it's not necessary for the structure of the control box. And as you can see from a picture I showed earlier, the layer that touches the heat bed prints out pretty terribly, so I need to diagnose that. I don't want something like that visible in front of the door, so I won't print it before fixing that issue, and that will obviously be after I'm done with the control box. So yeah, let's take a look at the assembled control box. So finally I've received the connectors as well. As you can see, I have 31 connectors in total. One of them is 16mm, the rest of them are 12mm. So 10 of the 12mm ones are 2-pin, and 10 of them are 3-pin, and the rest of them, 10 of them are 4-pin. And the 16-pin one is for the hot end heater, which is another 2-pin. So now let's just attach this to the control box, and as you can see, they do fit the panel quite well. I don't have any issue with it not fitting, which was a concern of mine because I didn't have these connectors in hand when I designed the panel, so there was a possibility that they wouldn't fit, but yeah, they fit fine. So yeah, they look pretty cool as well. So everything is now done with the control box, and now we can move on to actually moving into this control box. So here is the old control box. As you can see, I started to disassemble it, and it really hasn't been that long since I've built it. And if you don't remember, which you probably don't, since this was in like part 1 and part 2 of these videos, I built this in late summer. I built it out of aluminium sheets, as you can see, and yeah, it did go through a few modifications, like quote-unquote temporarily moving the Raspberry Pi and the relay board on top of the control box, which I never really moved back, and a few other modifications as well. But again, I had a lot of problems with this control box, which I explained in an earlier video, so I'm not going to go into that again. So I've disassembled it, so now I'm moving to the new control box. So again, I'm just going to go over a few pictures. So I just attached every cable to the power supply, as you can see here, because on the layer shift on the bottom part of the control box as well, it doesn't line up perfectly, so I'm not going to be able to screw it in, which isn't ideal, but it still stays in place. So I've done all the cable work on the downstairs chamber, and then routed all of the cables, as you can see, and then mounted the middle plate as well. So this is how it looks. And now I'm going to mount the electronics to the aluminium plates, which will go on the red plastic parts of the top layer. So this is the plan that I have for now. I might change it while I'm working on it, but I'll have the 4 LM2596 on the left and smaller panel, along with the MOSFET board, and on the right panel I'm going to have the MKS Gen, the relay board, and the Raspberry Pi. Okay, I know I just told you I showed you a different layout, but again, this doesn't happen like this in real life, so it is what it is. I mounted the MKS Gen, the relay board, and one of the LM2596s on this board, along with some breadboard with some pins, which is for the TMC2130s, which I'm not going to use right away. As you can see, I'm still sticking with TMC2100s on my motherboard for my 3D printer, but if you remember from a few videos ago, I received TMC2130s, which I will move on to, and I will need certain pins, etc. So it made sense to just use a breadboard for that. And now I'm attached that part and the smaller board as well. So on the smaller board I have 3 LM2596s and the MOSFET board. As you can see, I haven't mounted the Raspberry Pi to any of the aluminium plates. I just put it in a plastic enclosure, and I'm going to stick it somewhere on that middle plate. I just couldn't fit it properly in any of these parts, so yeah, I designed the control box with using the dimensions of all of these parts, but I didn't pay enough attention. And the problem with this Raspberry Pi is, if I put it where the breadboard is, or basically the old location that I showed, there was no way for me to plug in the USB cable, and if I rotate it again, then there is no way for me to access the SD card, and both of them are pretty critical. So yeah, this is the way it had to be. So yeah, this is the design, but it's hard to see on the picture. But if we look closely at the bottom part of the MKS CHAN board, as you can see, there is not enough clearance for the USB cable, so I have to remove the old connector and then just solder the wires directly to the board. And I'm terrible at soldering, but I don't really see any other way of doing this, so yeah, I'm just going to attempt that and then show you the result. And I fucked up. It's not visible in this picture, but while unsoldering the old connector, I lifted a few solder pads, and that basically ruined the USB connection. I tried soldering these pins here and then attaching a USB cable using some jumper wires, but yeah, it didn't work. I powered this board up and nothing connected, so yeah, I destroyed this board. So I don't really know what I'm going to do. If I decide to order another one of these boards, I don't really know a local source to order this from, and if I order from AliExpress, it will take a month or a month and a half to arrive, which I don't want to wait that long. And yeah, I don't really know what I'm going to do. I can go with a different board. If I, for example, decide to go with a duet Wi-Fi, it will probably take only 2-3 days to arrive. That is if they ship it immediately, because they have DHL shipping at a reasonable price, so I can do that. But yeah, I don't know, I can go with a smoothie board as well, again with express shipping. Yeah, I don't know what I'm going to do exactly. I will either buy the same board as this MKS CHAN, or I will go with a 32-bit board. And the reason that I want 32 bits is I have a problem with the signal generation. If you remember an earlier video when I was just moving to the flex-free drive, I had this problem where after a certain point the extruder motor just stopped, and it wasn't the motor that was at fault, it wasn't the driver that was at fault, it was the signal generation. So the 8-bit isn't good enough for that, so if I decide to go with a different board, that is something that I definitely want to do. So yeah, I don't really know what I'm going to do exactly. I will look at my options, and please feel free to comment any recommendations down below. I will read them. But yeah, right now, don't quote me on this, but I'm thinking towards ordering a duet Wi-Fi. Even though it's a pretty expensive board, I think it will be worth it. But yeah, I'm not sure. So anyway, I still hope you enjoyed the video. I'm sorry about my voice, I'm a bit sick. I'm sure it sounded terrible, but there isn't much I can do about that. And still, if you enjoyed the video, please leave me a like below, and thanks for watching.